Hello, this is Jesse Miles. This is my chapter 13 homework here, which was energy and momentum. It's kind of a two-parter here. This is actually the last problem on, I think it was the energy part of it. I was scrolling through the problems and went to the bottom and then came back, and I just imagined or thought it was the first problem. So I started with this one. Anyways, you have your T1, V1 equal T2 plus V2. That's used that quite a bit in this assignment, pretty much on every problem. Anyways, you do a bunch of substituting, solving obviously for unknowns. You end up doing the quadratic formula at the end and get 0.281 meters. This one, not nearly as much writing, but basically you get this little diagram down here. And just using basic trig, kind of, you just get that D right there, which is the distance or displacement, which was 9.53 feet. Next one here, I'm going to try and move a little quicker so I don't try and upload a big video, but you have your knowns, try and solve for your unknowns. Here we were looking for force of, what was it, tension and compression? Is that what those stand for? I forgot already. But yeah, so you get 7.41 kilonewtons and 5.56 kilonewtons. Okay, this one, let's see what we're looking for, distance or x, and then the force of AB, kips, and then force of BC was 8.62 kips. Both were compression. Next one here, you have MGL sine theta in there. Of course, your T1 plus U1-2 plus or equals T2. Use that one several times in this assignment as well. End up getting theta equal 14 degrees on that one. And this one was kind of cool. Yeah, look for your average power, your delta U over delta T. And then your max power is 229, and then divide that by a motor that's 85% efficient, and you get 269. Next one here, you have your x of A, B, and C. You put all your knowns in there. You had your 0.1 as your x of A squared, so 0.1, and then x of B was 0.05, which we found right over there. And then, let's see, come down. Oh yeah, you had your, which one was that? Your V of B of G. And then you come down here, you get V of B equals 2.48, and V of C equal, 2.48 to the left, and V of C equal 1.732 up. Next one was the truck up the incline here. You had your weight, your mass, which is just weight divided by 32.2 feet per second squared. Then you end up getting 621.118. And let's see, A was the first one we did. We're looking for the force, which was 2,277. And then you go to B. It was 9 seconds total. But I think the first one, yeah, we plugged in 6 seconds, so it was basically 3 seconds extra. Next one here, this was kind of a pretty interesting diagram to draw, but it wasn't too bad. This one, basically you solve for two equations that both have a capital T and a lowercase t, multiply by 2 on the second one to get, or to eliminate, two of those t's, and then you can add the other two together and use simple elimination, and then plug in your small t to get your large t. And let's see here, well, small t being time and large t being tension, of course. But let's see here. Next one, we were looking for initial velocity. I got 778.92 meters per second. Next one, we got 4.646 joules, and then C, we got the tension was 19.74 newtons with these equations here. Let's see, okay, last page. Okay, this one was where you had the 3 different balls, A, B, and C, and then you release A. So you have to get your VA, your VA prime, your VB, and your VB prime, all that stuff. So basically you do that, go step by step, and end up substituting a couple times, I believe, in there. And finally you get VB prime. You get basically the equations, and then you get to D and you sub in for V of 8 prime. And I got 0.698 multiplied by whatever the initial speed is, or initial velocity. And the last one here, this one was also one with a ball, kind of like a pendulum, and it also had a moving block as well. Let's see, where are we at on this one? Oh, right, yeah, because we were looking for the initial height there to where you were to drop the ball, or A, and I got 0.294 meters. And then you have several equations. You can kind of substitute things in for your mu, your mass, your gravity, and your x, and ended up getting the u of 1-2 is negative 5.886 multiplied by the mass of B multiplied by x. And then finally you get x, which is 54.4 millimeters, which was 0.0544 meters. I just changed it to millimeters because it looks a little better. But yeah, that is it, I believe, for my chapter 13 homework. Thanks.